This bonus video is designed to give you a sample of what you might do with practice problem 3, where you're being asked to start thinking about testing hypotheses with simple and multiple linear regression. We're also getting practice specifically with dichotomous variables as regressors. So we're using the stats data set, which came from a summer section of psychological statistics where they had people complete the survey, and we got over 200 responses. And there's lots of variables here. And in class, we cleaned up this data set. So there's quite a few variables, 58 of them. One thing I want to point out, I use the view command to get the data set here, is that if you have a large data set like this with over 50 variables, you're not going to be able to see them all when you scroll to the right. We only see the first 50. But you can see the rest of them if you click the right arrow here. And now if you scroll over here, you see this was the 50th variable, and you can see that there's the other 8 at the end. So just a quick note about that. So I've already loaded the packages that we will need to do this. And one of the first things that we're asked to do is to use the describe by function to get a series of descriptive statistics for our y variable broken down by our dichotomous x regressor. So which variables am I going to choose? Well, I am going to choose to try to predict road rage from, we'll call it x1, from whether somebody describes themselves as a type A or type B person. So those are my two variables for the simple linear regression. So I'm going to, my hypothesis, I'm going to call this hypothesis 1, is that people who report being type A are going to report experiencing more road rage than those who report being type B. Okay, so that's my first hypothesis. Pretty straightforward. And in fact, if you look at this hypothesis, it actually, as we've talked about in class, you could test this with a t-test instead of a regression. But this is a regression class, and we now know that t-test is just a very specific kind of regression. Okay, so since we have loaded our psych package, we can use describe by. And we have to use the name of for describe by, one of the slightly annoying things is we have to keep repeating the name of the data set, the data frame. So we want to know about road rage, and our grouping variable is the type AB. And then the data set is stats. I think that's right. So if we click run, okay, so we can see here that these are the type A results, these are the type B results, and we can see the mean for road rage is indeed a little higher for those who call themselves type A than those who call themselves type B. There's more type A people than type B people, about almost twice as many. And we got minimum and maximum and standard deviation and so forth. But mainly we just want to see, like, are the results in the anticipated direction compared to my hypothesis? And they are. So that looks good. So now I can go ahead and create the simple linear regression that tests this hypothesis. Now, most of the time, you're not going to do a simple linear regression, but it gets us to the multiple linear regression a little bit later on. So we're going to do the linear model where we are predicting road rage as a function of type AB, and our data is stats. And we can run that, creates that model, and then we can use the S function to see what we got. Okay, so our intercept is 1.26. So on that 0 to 3, remember road rage was measured. How often do you experience road rage? 0 meant never. 1 was seldom or rarely. 2 was sometimes, and 3 was often or very often. So this is not super easy to interpret what, somewhere between the values means 1.26. But this would be somewhere between rarely and sometimes. So, and then we have our regression coefficient for type A and B, and the baseline is type A. And this variable here, this regression coefficient of negative 0.111, says that this is the difference between the two groups. And you can see that it is. 0.11 is the difference between the two groups. And when we go from type A to type B, our scores on road rage go down by 0.11. So that's why this is a negative 0.11. So remember when we talked about dichotomous variables, that if you have a simple linear regression, the y is telling us, well, what is our predicted y score? What is the intercept is telling us? What is our predicted y score when x is 0? Well, x is 0 means type A, because R knows to code the first group as 0 and the second group as 1. So we can see that this is exactly equal to the mean of our type A group. So if somebody's type A, our best guess as to how much road rage they will report is 1.26. And then for type B, if they're type B, this regression coefficient tells us that it would be 0.11 lower than that, which is the mean here. So if you take 1.26 and subtract this, then you're going to get 1.15. So that's how we interpret those. Notice that my hypothesis was not supported because the p-value, even though it's in the direction we expected, type B people did report less road rage, but this coefficient is not significant. So this is not, we can't trust that in the population of type A and type B people that this would be greater than 0 or different from 0. And our R-square is pretty tiny, 0.003. So we're only capturing about 0.3% of the variability in road rage based on whether somebody calls themselves type A or B. Not so great. Okay, so that's how we would do that. What about multiple linear regression? What else am I going to add in? Well, let's see what other variables we've got here. We could also add in stress. Maybe people report experiencing more road rage if they're currently experiencing more stress. Maybe they remember the times where they've been sort of angry behind the wheel. So we're going to add in stress for our second model. Road rage as a function of type AB plus our new predictor, PSS, data equals stats. Before I hit go on this, I'm going to build in my second hypothesis. Controlling for type AB, people who have more perceived stress will report more road rage. That's my second hypothesis. So that's one way to say it, or holding type A B constant, or as we've talked about in class, there's a variety of ways to do that. We're going to go ahead and create that new multiple regression model with an x1 and x2. So now y is still road rage. x1 is still type AB, but now x2 is perceived stress. Run that. Now let's get the results. So what's happening? Okay, so now we've got something interesting going on. So now, if somebody is 0 on both of these things, which technically isn't true because while you can be type A, which is 0 on this variable, you can't have a perceived stress score of 0 because the scale goes from 1 to 5. But if somebody was off the charts with a 0 of perceived stress, which means they experienced less perceived stress, we would expect them to have a very low score on perceived road rage. So a type A person who is completely unstressed would say that they almost never experienced road rage. That's what the intercept tells us. What's our prediction for Y when our scores on X1 and X2 are both 0? So that would be a type A person with a 0 score for perceived stress, which again, it can't happen. So don't overthink this too much. The type A, type B is if we took two people who were the same score on stress, but one person was type A and one person was type B, the type B person would have a road rage score that was 0.1558 lower. Okay, so two equally stressed out people, but one's a type B person, one's a type A person. Type B person would report less road rage, which is similar to what we found here. It's actually gotten a little bit stronger, but still not significant. What about the new variable? What about our hypothesis about here, controlling for type A, B? People who have more perceived stress will report more road rage. Well, that's supported. If we take two people who are the same level, either type A or type B, so they're both type A or they're both type B, a 1 unit increase in perceived stress, which is a 1 unit increase on a 5-point scale, say from 2 to 3 or 3 to 4, will be associated with an increase in predicted road rage of 0.2966. So almost a third of a point from never to rarely, or rarely to sometimes. And this p-value is less than 0.05, and we have two asterisks here, so this is a significant result, meaning that perceived stress after controlling for type A-B does significantly increase our ability to estimate road rage experience. So our second hypothesis is actually supported. It's significant, but also importantly, it's in the expected direction. So it's positive. If this were negative, it would mean that the more stress you experience, the less likely you would be to report road rage. And that would be unusual, but that's not what we found. Our R-square also went up. Before it was not even 0.01. Now it's up to 0.05. And we can see that our overall model is significant with a p-value of 0.016. Okay, two last things to quickly do. First of all, we can see whether or not these two variables are super highly correlated with each other in the context of this regression and whether we need to worry about collinearity. Remember, in order to do that, we use the VIF function and we just enter in the model number. So we're just going to see if these two, and there's no hard and fast rules. And I mentioned that it's not as big a deal as sometimes people think it is, but if you got VIFs that were really, really high, way over 10, then you might be concerned about it. So these results tell us that we do not have an issue with collinearity. These are well below 10. Again, 10 is just a rough guide. It's not something you should use as gospel, but these are nowhere near that cutoff that sometimes people use. And so it's just a quick check. We're not having any issues there. And then the last thing that we want to do is just see which of these two variables is more important in contributing to the prediction of road rage. And while we know one is significant and the other one is not, in order to be absolutely sure, we can use the semi-partial correlations to estimate the relative importance of one variable versus the other. So remember, we have to use the JTools package. So if you haven't already done so, you would want to install JTools and then load it with the library function, or just going to JTools in your list and clicking that. And we use the summary function in JTools and part core equals true to get the semi-partial correlations. And these you can safely compare to each other to determine which one is increasing the estimation power of our regression on top of the other one. So what we can see here is that the partial correlation, the semi-partial correlations, which remember in the previous video I mentioned is also called part correlations. So remember, semi-partial correlation is the same thing as a part correlation. They're just two names that people apparently can't agree on what to call them. So we have our semi-partial correlations here. The stronger of the two, ignoring the sign, is perceived stress. And that doesn't surprise us, but it is the larger of the two. And we ignore the fact that they're in different signs. So that's it. That's pretty much how I, using these variables as an example, would go through the practice problem set. Hopefully this will be helpful as you work through it yourself, using the variables that you're interested in making hypotheses about to test with the data set. Okay, good luck.